Hi there, this is an AG32 microcontroller. Inside it's a RISC-V microcontroller and a little FPGA fabric on the same chip. So in theory, this is a bit like a Cypress PSOC where there's like an infinite pin mux, or it's a bit like a Raspberry Pi Pico with the PIO state machines, except it's not like either of those. It's a full RISC-V microcontroller with a full 2K LUT FPGA hanging off the bus. The problem with this chip is you can only get it off of Taibo and LCSC. The official toolchain was hidden behind a Baidu NetDisk server. So this is my project, AGaMEMnon, to build all of the synthesis, the routing, the placement, bitstream generation, and programming without ever using these vendor tools. So right now we're going to go into the scripted demo because I am doing this very live, and we can check out the version of AGaMEMnon. We can probe the chip, and we can look at the Verilog we're going to do. This is a tiny little 24-bit counter. The counter advances on the FPGA clock, and the most significant bit drives an onboard LED. This should show that exercising sequential logic, flip-flop feedback, and a dedicated carry hardware, all of this stuff to actually make an FPGA work. So we can build this and look at HTOP showing it is building. There we go. This will take just a second, but I do have other demos that work. I have a complete serve core, which means I have a RISC-V core running on the FPGA alongside the RISC-V solid core. So it's two FPGAs in the same package. I am going to flash this now. Boop, boop. And you can see right here, boom, we have a blinking LED. That is proof of life for an open toolchain for an FPGA no one has heard of. If you'd like to check out this project, well, you're probably on this webpage, but go to the AGaMEMnon project on GitHub, and that will allow you to run everything. This is running on a Raspberry Pi 4, so it should run on everything. Yeah, thanks for checking this out.